This is day one of our rational function unit where we are solving rationals. And today we're going to be multiplying and dividing rational functions. So to start, let's write down our directions for multiplying rational functions. So to multiplying rational functions. So step A, factor each term completely. Don't worry about my spelling. B, combine numerators. Third step on these is we combine denominators. And D, cancel the identical terms from numerator and denominator. And that means you have to have one on each the top of the fraction and the bottom of the fraction. Okay, so 4 steps. We factor each term completely, we combine our numerators, combine our denominators, and cancel identical. So here's our first example. And let's start with one that's already factored. Okay, so we have x plus 1 multiplied by x minus 4 over x plus 2 multiplied by x plus 1. And this whole fraction we want to multiply by x plus 2, x minus 6 over x minus 4. Now typically we don't put parentheses around something when it's the only thing in the numerator or denominator, but we assume it's there when we're multiplying them. So go ahead and put parentheses around this. So we've already got it factored. Top left is factored, bottom left, top right, and bottom right are factored. So now we want to combine them. And by combining them, that simply means we're extending this dividing line. So now we have x plus 1 times x minus 4 times x plus 3 times x minus 6. Well, same thing with the denominator. And we want to start canceling our terms. I'm just going to cancel these using a different color. So I have an x plus 1 in the numerator and 1 in the denominator, so I can cancel those. I have an x plus 2 in the denominator and in the numerator, so we cancel those. We have an x minus 4 in the numerator and denominator, so those get canceled. And we are left with x minus 6, and if everything's canceled, by default that's a 1. And typically we would just write that as x minus 6. I hope that made a little bit of sense. So let's try our second example. Example 2. This time we have 2x plus 4 multiplied by x minus 1 over x squared minus 1 multiplied by x plus 1 times, or over x plus 2. Now again, I said if there are no parentheses around your numerator or denominator, go ahead and let's put those in to begin with. And this time it is not factored completely. So if you notice that we have 2x plus 4, and do you recognize that there's something in both those terms that we could factor out, and that being a 2. So we're going to rewrite that as 2 times x plus 2 times the x minus 1. So I've rewritten my numerator. Now my denominator, although there's only 2 terms here, x squared minus 1, hopefully we recognize this as the difference, that's the minus sign, of 2 squares. So my factors are x plus 1 multiplied by x minus 1. And again, I'm going to just cross that out because I've replaced it with its factors. Now that we've got everything factored as much as we can, we're going to combine our numerators and denominators. And by combining them, I just extend that dividing line. And now I look to cancel any identical factors. So let's see, what do we have that's identical on the numerator and denominator? I have an x plus 2 in the numerator and in the denominator, so we'll cross those out. I have an x minus 1 factor in the numerator and in the denominator, so we'll cross those guys out. X plus 1 in the numerator and in the denominator, so again, we cross those out. And we're left with, on the top, I just have a 2, and on the bottom, it's really just a 1. There's nothing there. So by default, it is a 1. So that those two rational functions multiply to give me a 2. Okay, let's try another example here. Let's see, example 3. So this time we're going to have x plus 6 over 3x minus 6 multiplied by 2x plus 8 over x plus 4. Okay, let's take a look here and see what we can do. We've got a factor, first of all, so my rational expression on the right, 2x plus 8, I know that I can factor a 2 out of that, so it's 2 times, if I take a 2 out of the 8, I have a 4. Okay, and my rational on the left, the denominator, I can factor a 3 out, so I'd have 3 times x minus 2. And again, if I were to distribute that 3, I would get what I just crossed out. And now we extend our dividing line. Let's put those parentheses in there that we were missing, and see what we can cancel out. I have an x plus 4 and an x plus 4, so we'll cross those out. And it doesn't look like there's anything else that crosses out here. So on the top, do I have anything left? I have a 2 and an x plus 6. So we typically would write it with a number out in front, and then by binomial behind it. And here we have 3 times x minus 2. There is no need to distribute the 2 or the 3 when we're just multiplying these guys. Okay, let's take a look at one other one. Example 4. And again, on some of these, we need to get used to factoring. They are going to be given to us in the unfactored form. So here we have x squared plus 7x plus 12 divided by x squared plus 4x plus 3 multiplied by 1 over x plus 4. Okay, I'm going to put parentheses around the x plus 4, but I need to factor these guys. So for this one, the numerator, I need to do that x factor. I need things that multiply to give me 1 times 12, so 12, and add to 7. Okay, 3 and 4 will meet that. So my factors here are x plus 3 and x plus 4. The last step, remember, when we factor is dividing by our a value, but it's 1, so we're okay there. My denominator, I need things that multiply to 3 but add to 4. So 1 and 3. So x plus 1, x plus 3. And again, if you want more practice with this, check out Khan Academy or come see me and I will give you some practice worksheets on factoring. So we've factored, we now combine our terms and start canceling. I think this is always the funnest part. So we've got an x plus 4 and an x plus 4. I have an x plus 3 in the numerator and an x plus 3 in the denominator. So my numerator, I'm left with just a 1. The denominator, I have x plus 1. Now some of you may wonder, can I cancel these two 1s? And the answer is no. You can only cancel things that have been multiplied together. This 1 is added to the x, so I cannot cancel it. So that's my final answer there. Okay, let's take a look at dividing rational functions now. So we've got the multiplying down pat. Let's take a look at dividing. Oops. Okay, so to divide rationals, let's step A or 1, whichever you prefer. We need to factor completely. We need to when we multiply fractions, we take the bottom fraction and have to take the reciprocal of it. So some of you learned this as keep, change, and flip. And I'm just going to show you real quick on the side here. If I had 1/2 divided by 4/6, for instance, we keep the 1/2, we change the division sign into a multiplication sign, and flip the second fraction. So that's what we're doing. We're keeping, changing, and flipping. Step C, we combine the numerators. Step D, combine denominators. And step E, cancel identical terms. And again, we have to cancel 1 from the numerator and 1 from the denominator. Oops, that went off the page. So notice that when we divide rationals, it's exactly the same as multiplying, except for step B, where we have to take the reciprocal of the second term, second fraction. Okay, so let's get some examples so we can see how this works. So example 1. Let's take x plus 1 times x minus 1 with a denominator of x plus 4 multiplied by x plus 1 divided by x minus 1 times x plus 7 over x plus 7 multiplied by x plus 4. Okay, so we're given this already. So we don't need to factor it because we're given it factor form. So our second step is keep, change, flip. So this first rational expression we're going to keep exactly the same. I'm just rewriting it. Everything is in the same position. We change our division sign to multiplication, and now we flip or take the reciprocal of our second rational. So everything that's in my denominator becomes the numerator. So it's going to be x plus 7, x plus 4. So notice that one there. My numerator is going to become the denominator. So x minus 1, x plus 7. And now we extend our divide line and start canceling. So I have an x plus 1 in the numerator and I have 1 in the denominator. I have an x plus 4 in my denominator and 1 in the numerator, so I can cancel those. I have an x minus 1 in both locations, and I have an x plus 7 and divided by x plus 7. Once we're done canceling, it looks like there's nothing left on top and nothing on the bottom. So that means that everything in the bottom divided into the top. And just like if you had a number, say 5 divided by 5, that equals 1. So anything divided by itself gives you 1. Okay, let's take a look at a second example. Let's do one where we do a little bit of factoring. So x squared minus 1 divided by x squared plus 5x plus 4 divided by x squared plus 6x minus 7 divided by x squared plus 11x plus 24. Lots of factoring here. So we want to go ahead and factor first. So here we've got difference of two squares. So my factors are x plus 1, x minus 1. Down here my factors are x plus 4 multiplied by x plus 1. And again, if you need more practice factoring, come see me or get on Khan Academy. Factors of -7 that add to 6 are x plus 7 and x minus 1. And factors of our denominator are x plus 3 multiplied by x plus 8. So now I need to rewrite this guy. My factors on the left stay in the same spot, so x plus 1 multiplied by x minus 1 divided by x plus 4 times x plus 1. Change my sign. So I kept my first rational. I changed the sign to be multiplication, and now I flip. I take the reciprocal, so my denominator becomes my numerator. And then I will just multiply. Okay, so let's see what we can cancel here. Extend the dividing line. I have an x plus 1 and an x plus 1. I have an x minus 1 and an x minus 1. And I'm afraid that looks like all we can do. Okay, so in this case, I'm left with an x plus 3 multiplied by an x plus 8 over x plus 4 multiplied by x plus 7. Okay, there we go. Let's do a couple more examples here just to make sure we're comfortable. So let's say example 3, and I'm going to do one that's already factored this time. So 2 times x plus 5 multiplied by x minus 4 over x plus 5 times x plus 6 divided by 6 times x minus 4, x plus 3 divided by x plus 3 multiplied by x plus 6. Ugh, a lot of stuff there. Okay, let's take a look at this guy. I rewrite the first fraction. So x plus 5 times x minus 4 divided by x plus 5, x plus 6. Change the sign to multiplication and flip, or take the reciprocal. So x plus 3, x plus 6 becomes the numerator, and 6 multiplied by x minus 4 times x plus 3 is what I'm working with. Extend that dividing line and let's start canceling. I have an x plus 5 and an x plus 5. I have an x minus 4 and an x minus 4. X plus 3, x plus 3, x plus 6, x plus 6. So we're left with, on the top, 2, and on the bottom we have a 6. Now hopefully we all recognize that that is not reduced completely. That can be reduced to 1/3. So 1/3 would be my final answer on that problem. Okay, one final problem, and then you're ready to go. So example 4. We'll do one that has not been factored. X squared plus 9x plus 20 divided by x squared plus 2x minus 8, and that whole rational expression divided by 2x squared plus 26x plus 80 divided by x squared plus 6x minus 16. Ooh, lots of factoring practice here. Okay, first let's take a look at our first fraction, our first side, the numerator. So I need things that multiply to 20 but add to 9. Okay, so that will be a 5 and a 4. So I'm going to go ahead and start rewriting this fraction because I don't really have enough room. So that came down to here. My denominator, I have things that multiply to -8 but add to 2. So x plus 4, x minus 2. I'm going to change this sign. So dividing goes to multiplication. Okay, so my numerator in the new fraction is coming from the denominator here. So notice the difference here. So my denominator becomes my numerator. I need things that multiply to negative 16 but add to 6. So x plus 8 multiplied by x minus 2. And finally, my numerator is going to become the new denominator. But I notice that there's a 2 in every term, so I need to bring that out. So if I brought a 2 out, and we have 2 times x squared plus 13x plus 40. Okay, so when I bring this down here, I still need to keep that 2 out in front. And now I need things that multiply to give me 40, but add to 13. So x plus 8 multiplied by x plus 5. 8 and 5 multiply to 40, and 8 plus 5 give me 13. But again, that 2, that greatest common factor, I still keep. Doesn't disappear. And now we get to extend our dividing line and start canceling. So we have an x plus 5 and an x plus 5. In my numerator, I have an x plus 4 and 1 in the denominator. X minus 2, x minus 2, x plus 8, x plus 8. So look at this. On the top, it looks like there's nothing left. And again, after everything is crossed out, remember your remainder is a 1. And on the bottom, everything is canceled except for the 2. So it comes out to just 1/2. Nice and clean. Okay, so you are ready to start on the homework. If you do not have it, check my website. It is listed there also.